Hello and welcome to Maths with Jacob. This lesson will focus on curved graphs. So far we have looked at straight lines on a number plane. There are many examples of curves that can also be graphed on a number plane. Equations that contain powers or indices give us a clue that some sort of curve is involved. For each of the following, draw up a table of values and graph the curve. So for this equation here, y equals x squared, this is the power here, 2, or the index. When you have that situation, that's a very good clue that we have a curve involved. So basically it's always up to us to choose whatever x values we want. So I've just chosen these ones from -3 to +3. So when you substitute each of these x values in turn here, you end up with these y values. Now it's important to remember, for example, when we're substituting -3 for x, this actually means there's your -3 and that is squared. The reason I put that in, it gives you a clue that the -3 is squared. That whole number is squared. That's why we end up with a positive number down here, and it's the same for all those there. The positive numbers are easy. Once these 7 points are plotted on the number plane, we get something like this. See all those red dots there? And you can see that you can't form a straight line there, so if you just sketch it, that is just a rough idea, you can see that there's a curve there. Okay, definitely not a straight line. So after the points are plotted, the curve is obvious. It is called a parabola. So that's the name of that curve. The next example, y equals x cubed. So here we have a power of 3. So we know that there's some sort of curve involved. So here we've got y equals -3 all cubed. So that's basically similar to the last one, but this time it's cubed. So -3 all to the power of 3. And what that means is -3 times -3 times -3. That's what that means. So basically you have -3, because it's cubed, that means you multiply it by itself 3 times -3 times -3. -3 times -3 is +9. +9 times -3 is -27. So that's why you get a negative number. And it's the same for these. And then we substitute those values in. So there are our values. Now, when you plot these points, -3 -27, that actually falls right off the graph, so that's okay. But we can plot -2 -8. We can plot -1 -1, 0 0, 1 1, and 2 8. So when you plot those, that's 1 2 3 4 5 6 7 8. So when you plot that, that's an interesting looking curve. You can see that's the curved section there. In fact, they're curves all the way. It looks like it's a bit of a straight line, but they're actually curves, and that's called a cubic. Over here we have an x squared. Normally when you have an x squared, you have a parabola. A curve that looks like this. So we put down some x values. We substitute each of these x values into here, one at a time, and they're the y values we get. When we plot those on the number plane, again, it is a parabola, but it's shifted down here. If you remember the first example we did, it was a simple parabola here that sat there, but this one, because it's a little bit more involved, it's got more terms in it, it actually shifts the parabola into a different position on the number plane. So anytime you see an x squared, that's a very good clue that it's a parabola. So this video has shown us how to draw a few basic curves on the number plane. All you do is construct a table and then you find a number of points, normally 4 or 5 points, 6 points, and then you can quite easily sketch the curve.